All right, our final unit of the year is geologic history, studying the history of the Earth. Got you a little picture here of what's called the Eurypterus. This is the New York State fossil. It can be found on page 1, bottom of the reference table. Um, we're going to talk initially here about fossil evidence first. Okay? So the fossil record is how we track our past history. All right, so what is a fossil? Fossil is the remains or evidence of a once living thing. We use these fossils as markers. If we know when the organism lived and we find that fossil in that rock, that tells us approximately how old that rock is, so that allows us to put things in chronological order and figure out the history and how it's progressed through time. So, how do fossils form, generally speaking? All right, first of all, remember fossils are only found in sedimentary rock. They're actually quite difficult to find. Most fossils are incomplete because you can only get the hard parts to become fossils usually. All right? When something dies, by the time it gets buried and fossilized, all that flesh, the soft parts, the innards, the yummy stuff, that's either been eaten by animals or it is decayed away before it can become fossilized. So we don't normally find any soft tissue. Right? Occasionally things happen in certain environments where we can get stuff like that, but not very much. Usually it's bones that we get, usually it's the hard parts. All right, so here's basically how something becomes a fossil. All right, so first of all, something has to croak. All right, something dies, kicks the bucket, buys the farm, whatever. All right, that area has to become submerged. Okay, remember sedimentary rocks, sediments get washed downstream, dumped into large bodies of water. So in order for things to get buried, usually it has to be in a water environment. So, the land has to sink down, water levels rise, the dead organism gets buried. Over time, even though the soft stuff gets eaten by fish and the squishy parts decay away and that kind of stuff, the hard parts eventually, at least some of them, usually will get buried by sediments. Then over time, they get compacted. That sediment gets lithified, turned into rock, compacted, right? Remember that? And then sometime millions of years later, some tectonic forces, some uplift of some sort, right, is going to weather the rock away. It's going to come back up above the surface of the water, get weathered away, and eventually the fossil starts to get exposed at the surface. Someone's walking along and they trip over something, and then all of a sudden they start digging, and there you go, you got a dinosaur fossil or whatever you're looking for. Okay, so that's generally how it happens. All right, we got different types of fossils that we find and work with. All right, first is called a mold and a cast. This is what happened. I'll give you an example. When Pompeii erupted in 79 A.D. and buried, when Vesuvius erupted in 79 A.D. and buried Pompeii, it happened so quickly that the entire village was pretty much buried as is. And then over time, it hardened real quick, and they couldn't get out. It was like an avalanche, so to speak. The pyroclastic material kind of buried them. And then over time, their bodies decayed inside, and it left a big hole, a space in the rock. Well, when we excavated that site, we found these holes in the rock, and we filled them with plaster, and that's kind of what we get here. Is we have these people. We have this museum actually in Italy that has these casts of different people and animals and things like that from when that eruption occurred. Okay, so this is a mold, and this is a cast. All right. We can get an imprint, an impression. So something lands on, something walks on soft sediment, a dog paw print or a deer print. Right? And then if that mud hardens into rock, that's an imprint. All right, and that is a fossil. It can be a fossil if that layer of rock becomes buried, and that imprint is discovered millions of years later or whatever. All right. Amber, tree sap. Right? Insects land on sticky tree branches. They get buried in the tree sap. They get embedded. The branch falls to the ground or whatever. The sap gets buried underground for millions of years, and then pretty soon you have amber. All right. Ice is a fantastic preservative, right? We freeze things in our all the time in order to make them last a long time. Well, other things that get frozen will last a long time too. This picture is a baby mammoth that was dug out of the ground in Siberia. Actually, they found the stuff that he had eaten still in his stomach, grass and things like that was still in his stomach. It was so well preserved. Tar. Tar is a great preserver. It's basically oil that bubbles. It's a sticky oil that bubbles to the surface, and then an animal might get caught in it and get trapped and then buried, and it preserves the animal pretty well, just like ice does. Right? Petrification. You may have heard of petrified wood. That picture on the right there, it looks like a log. It's actually a rock. It's in the shape of the log because over time, when you bury a log in that environment, minerals that are in the ground slowly replace the wood fibers, and so you now have a rock that looks like a piece of wood. Right? It's not wood anymore. It's actually rock. It's mineral material, but it looks like a piece of wood, so we call it petrified wood. It's not still wood. It's actually a rock. Right? All right, how do we interpret fossils? What do they do for us? All right. First thing they tell us is that throughout history, there have been different kinds of life. Okay? We can see all the different types of organisms that have lived through history. Not all of them, but a lot of them. All right? When we take those fossils and arrange them according to the age, when we date them, when we have techniques for dating those fossils and finding out approximately how old they are, we show evolution. This is how we can show evolution through time. Is we put these organisms in chronological order, and we can see gradual changes to the species. Right? Response to the environment causes change in the species. They have to evolve in order to adapt. Right? They also show us how the Earth's surface has changed over time. I already used the one example before of you might find a marine fossil at the top of a mountain. Well, we know that those organisms didn't live on the land at the top of mountains. So that means that it must have died, got buried in sediment and turned into rock at the bottom of the ocean, and then the ocean crust must have been uplifted to create that mountain. Right? So it tells us how the surface has changed. They tell us about the activities and the appearance of past life forms. A good one is teeth. Right? This is a Smilodon. You might have known it as the saber-toothed tiger. Right? But look at the incisors on that thing. These teeth give us a clue. And the large paws, we think, well, we know, based on the teeth, that it was a meat eater, okay? But we think that it was the way it attacked, the way it killed, was that it would pounce onto its prey, grab on with its paws and hold on, and sink those incisors into the neck, and just hold on until the thing died, and then it would eat its fill, all right? If you see teeth that are very flat and wide, that'll tell you probably that it was an herbivore, that it had to chew plant material and grind plant material like your molars in the back of your mouth. All right? But you can tell a lot about fossils by the animals by what kind of teeth they have. Right? They also tell us about the past climate. And I've already talked about the corals. All right? Corals exist in warm tropical waters, and we can infer then that areas that have fossilized coral, that coral limestone, must have had a warmer climate. And since we find coral limestone here in New York State, we conclude that New York State once had a warm tropical climate. It's just deducing things based on the evidence you're given. Right? All right, we have a special type of fossil. Okay, now whenever you find you dig in or whatever, you find a fossil, it could be cool, whatever, but not all fossils are geologically important. All right, the only ones that are geologically important have to fit a certain criteria. We call them index fossils. If you think about what an index is, an index in a book is used to find where things are. Well, a fossil can only be used geologically to date where things exist if we know a couple things about that fossil. One, it has to have only lived during a really short time, geologically. Maybe it only lived for 100,000 years and then it went extinct. So if we find that fossil, we know that small time frame is when it lived. And we also have to find it over a really large geographic area. Okay? For example, if an organism only existed in California, we can't use it to date a rock that we find in New York. All right. This guy right here, we have a little skeleton there and a little artist rendition of what it might have looked like. This is called a Coelophysis. You can see the paw prints in the bottom left. This is the only known dinosaur that's ever to have existed where New York exists now. And the only reason we know it was around here is because we have found these prints down here, down near New York City. All right? We have never found an actual skeleton. This skeleton was from another state. Okay? We've never actually found a real full or any bones at all here in New York yet, to my knowledge. But we do have prints in the rock. We've excavated prints down near New York City. So we know that it did exist around this area. We just haven't found any actual bones yet. All right. So what does that tell us? This tells us a lot. When we look at fossils, it tells us a lot about evolution. All right. We haven't talked about the timeline yet, but the oldest time frame that we're going to talk about is something called the Precambrian. And what geologists noticed is that if you go back older than about 580 million years, we can't really find any good fossils. All right? There's nothing. Remember, how we find fossils is we find hard parts. So what the geologists use from that information is that tells them that those organisms were not able, anything that lived prior to about 580 million years ago was not able to become preserved because they didn't have any hard parts. They were very simple organisms, right? Soft-bodied organisms, jellyfish, that kind of thing. And those things don't preserve well. So we have actually found right around 560 to 580 million years ago, is we found that before that time, we don't have a very good rock record. We don't have a very good knowledge of the history of the Earth. Essentially, the first 88% of Earth's history we know very little about. We have a really good fossil record from the last 580 million years, which is 12% of history or something like that. But other than that, not really that well. What they think also is that the rocks containing fossils probably have been destroyed by plate tectonics. Okay, remember we said a lot of those oceanic crusts have been recycled. So if there were any organisms that lived at that time and created fossils, those fossils would have been destroyed during metamorphism and weathering and all that kind of stuff. So between those two ideas that there weren't very many hard organisms with hard parts, and the fact that any fossils that were there probably got destroyed, we don't find a whole lot of fossil record in that Precambrian, okay, in that old eon period. Right. This also tells us that shows us the fossil record is incomplete. We also know the fossil record is incomplete. All right. Not every fossil that's ever existed created a fossil, so we do have gaps in the record. Right. We're able to figure out pretty well about a lot of things, but there are some gaps that we lack information about because not everything that has ever existed on the planet gets fossilized. Right? We do know that present-day organisms are more complex than past organisms. Darwin, in his theory of evolution, he suggests that organisms that have beneficial characteristics will survive to pass those traits on to their offspring. So as we see things changing through time, we know that they had to adapt in order to survive. So that tells us that as we move through time, things get more and more and more complex. All right? Any organisms that didn't have good characteristics are going to die off in what's known as natural selection. All right? So some species have become extinct through time, and some have we developed new ones through time also. So things have changed through time. All right?